Good morning, everyone. We were discussing about neural network. So we have came across perceptron unit. Problems can be the problem, whatever you address, it can be linearly separable problems, non-linearly separable problems. So in case of linearly separable problems, if you are trying to address the problem using neural network, we'll make use of perceptron unit. So this was the structure of perceptron unit. Yeah, we have seen like perceptron unit, it takes the input, various input, and various inputs along with the weights. So linear combination of these inputs along with the weights, if the value is greater than or equal to 0, we'll consider output as 1. Otherwise, if it is less than or equal to 0, the output will be minus 1. So that is what we have seen in perceptron unit. That is input and weight combination. If the summation of input and weights, that is the linear combination, if it is greater than or equal to 0, output is considered as 1, otherwise it is minus 1. So this was perceptron unit and it is applicable for linear problems. If the problem you are addressing is non-linearly separable, then perceptron unit won't work. For in those cases, in those situations, we'll go to sigmoid unit. In sigmoid unit, what we are doing is just observe the diagram. See, this is the sigmoid unit. Okay, inputs x1, x2, x3. Inputs are taken along with the weights. Okay, input and weight combination. Here also, summation of input and weight is calculated. You can see here we call it as net. That sum we are calling it as net. Summation of weight and input w naught into x naught plus w1 into x1 will go up to wn into xn. That summation of these values, this combination, we are calling it as some value, sum. This is the sum. Okay, we are calling it as net. Okay, summation of input and weight combination is taken, and it is provided as input to a squashing function. Okay, we call it a sigmoid function or squashing function. So output is dependent on input. It is not like you are going to get 1 or minus 1. Okay, this squashing function, what it will do is, see, O output is equal to the sigma of net. Net is nothing but the sum whichever we got, x into w plus x1 into w1 plus x2 into w2. That sum, okay, output is equal to sigma into sum, which is equal to 1 divided by 1 plus e to the power of minus net. Net means sum. Okay. So here in sigmoid unit, output is dependent on the input values. It will range from 0 to 1. It may be any value, zero point 0.5, zero point 0.6. You'll get the values, real values like that. But in perceptron unit, what we were assuming, like if the output is greater than or equal to 0, we'll call the output as, if the sum is greater than or equal to 0, we'll call the output as 1. If the sum is less than or equal to 0, we'll call it as minus 1. We were giving the threshold. The 0 was the threshold over there. Based on this sum value, we used to call 1 or minus 1. That is why it is applicable only for linearly separable problems. But in sigmoid unit, what we are doing is, we'll take the input and weight combination, do the summation, calculate the sum, and output is dependent on this sum value. Okay, output is equal to 1 divided by 1 plus e to the power of minus sum. So here in sigmoid unit, output is dependent on the sum. Is it clear? Their output was either 1 or minus 1, only two outputs. Here it is output is real value. You may get many values, okay, zero point 0.1, 0.5, 0.23, anything. So output is the function of input. Is it clear? Whatever we are getting the output, that is nothing but it is a function of input. So Sigma, we call it as sigmoid function or squashing function because it will squash the input into some value. See, this function we call it as sigmoid function or squashing function. Why we call it as squashing function? Because output is input is squashed into some value. Some value. Whatever output you get, it is nothing but the combination of some input and squashed. Okay, it is a combination of some inputs and its values. Is it clear? So this is sigmoid unit. Uh, and here also important thing is in neural network always the main concern and main thing is calculation of weights. See, this calculation you are doing when you provide the input to the network. We'll do this calculation. Okay. The next task is how to assign the weights for our input. Uh, See, the output is nothing but input and weight combination, summation of input and weight combination. So next task is how we are going to uh, assign the weights to the input. Okay. From here, we will call this as multi-layer neural net. Multi-layer means we have input layer, hidden layer, and output layer. So it is called as multi-layer neural network. All the neural network usually it will be multi-layered itself. Is it clear? Multi-layered neural network. Multi-layered means we have input units, we have hidden layer, input layer, hidden layer, and output layer. Is it clear? So each layer will have units, number of units. Those units we call it as sigmoid units. Those are the nothing but sigmoid units. And in each sigmoid unit, once you provide the input, these calculations will occur. That is, it will calculate the linear combination of input and weight, and then it will apply this squashing function. At each unit, this calculation is performed. Is it clear? So, see, first thing is calculation of output in each unit. That is, we call this as feed forward network. Why feed forward means we provide the input, and from the input, we are going to calculate the output at the next layer. Okay, so this is the sigmoid unit. I will just show you the neural network, how it will be. So this is one example for a neural network, multi-layer neural network. First layer is input layer. Okay, first layer is input layer, and we have two hidden layers here, and then the output layer. Is it clear? This is one example for a multi-layer neural network. We have input layer, two hidden layers. See, hidden layer, you may have one hidden layer or two hidden layer. It depends on the type of problem you are trying to address or solve. So in this example, we have two hidden layers, and finally, always there will be only one input layer and output layer. Hidden layers may be any numbers, but input layer either will be only one input layer and only one output layer. So input layer, three inputs are there. So this is a network which has got three inputs and two output. Okay, three input and two output. And these are not the sigmoid unit. From here, we call them as sigmoid unit. These are input points. Okay, x1, x2, and x3 are the input points. From here, input will go to these units. This is one sigmoid unit. This is another sigmoid unit. This is one sigmoid unit. Again, sigmoid units. All these are sigmoid units. Even these two are sigmoid units. Is it clear? See, these are input points x1, x2, and x3. And these are sigmoid units. These are sigmoid units in our network. See, as I said, it depends completely on our problem, what you are trying to address. If you are trying to design an AND gate or two input AND gate or XOR gates, how many input layers will be there? How many input units will be there? Two input AND gate means only x1 and x2. Two units, two points will be there, x1 and x2. If it is three input XOR gate, x1, x2, and x3. And get output unit will be only one. Either it will be 0 or 1. Okay, always input and output units depends on the type of problem you are trying to address. In the first class, we saw digit recognition example. Okay, digit recognition example. In a given image, you need to find out what digit it is, 0, 1, 2, 3, or 4. If that is our case, how many input units will be there and how many output units will be there? Output units. See, in digit recognition, if the image is 25 by 25 pixel, okay, 25 into 25, 625. Here, 625 input units will be there. Is it clear? 625 input units will be there. X1, X2, up to X256. That many input units will be there. And output units, how many digits are there? 0, 1, 2, and 9, up to 9. So 10 output units will be there. Is it clear? Whatever problem you take, for that problems you should know how many input units and how many output units. Okay, while doing I will explain you a complete implementation of neural network, wherein we shall take one example and we shall check how many input layers, how many output unit, how we are going to get the output, all those things. Is it clear? So these are input points. Assume that, okay, we have one problem wherein three inputs we are getting and two output. Okay, three input and two output, x1, x2, and x3. These inputs, this x1 will go to all these sigmoid unit of hidden layers. X2 will also go to all. You can see the arrow marks. From each unit, from each point, input will go to all the points in the sigmoid units. Okay, here in the first sigmoid unit, it will receive the input x1, x2, and x3. In the first sigmoid unit, it will take input from all these input points. For that, you need to add weights W1, W2, and W3. Is it clear? This sigmoid unit, it will receive the input from these 3 points, x1, x2, and x3. And we have to add the weights to that, and we have to calculate the sum. Once you calculate the sum, you need to calculate the output finally. Output is nothing but the combination of that is squashing function. We have to apply squashing function here. Squashing function means is nothing but this thing. Okay, we got the sum. We have calculated the sum x1, x2, and x3 along with the weight combination. You will calculate the sum, and output you will calculate by applying the sigmoid function or squashing function, that is 1 divided by 1 plus e to the power of minus sum. So then we are going to get the output at this point. Okay, we'll get the output here. So output is generated at this unit. Again, you have to calculate one more output here. See, all these are sigmoid units. Okay, here I will calculate output 1, output 2, output 3, and output 4. Is it clear? See, x1, x2, x3, along with some weights W1, W2, W3, W4, W5, and W6. We'll add the weights, we'll combine the input and the weights, we'll calculate the output at each of these sigmoid units. These are sigmoid units, and we'll calculate the output at each of these sigmoid units. Once you calculate the output here, so this output will become input for the next layer. Output 1, if we call it as this output as O1, so this output will become input for the next layer. See, that is how neural network works. Okay, if you have 2 or 3 sigmoid layers, input of one unit, output of one unit will become the input for the next unit. So here, whatever output is generated, that output will be fed. That is why we call it as feed forward network. This output is fed as input to this next layer. So from here, again, we have to do the same calculation here. Okay, we have to do the same calculation here. Combine the weight and the input and calculate the sigmoid function. Apply the sigmoid function and calculate the output. Here also for these 4 sigmoid unit, you'll get some other output. Is it clear? Here also we'll get some other output. So this output is again provided as input to the output layer sigmoid unit. Okay, here also four output will get. These four output will be provided as input to the next layer, that is output layer. Here output layer has got only two sigmoid units. It has got only two sigmoid units. So these input along with the weights. Here also we need to add some weights, and that calculation, sigmoid calculation is done here at these 2 points. Finally, we'll get some final output. Assume that you got 0.24 here and 0.26 here. See, that is the output which we got when we apply the input along with some weight combination. Okay, that is the generated output. And we have seen whatever output we get, I was getting 0.24. Okay, 0 okay is nothing but the output generated. So you have to calculate this difference. You have to do this calculation at the output unit, and we call it as error delta k. At each output unit you have to perform this calculation. Okay, once that calculation is done at output unit, then you have to go for one layer before, that is you have to go to hidden unit. Okay, go one layer back. At each hidden unit you have to do this error calculation. Okay, when you see delta h or delta k, it means that it's the error at that unit. And at that unit, what you must do, output of that hidden layer, even hidden layer has generated some output, minus one of output of that layer into summation of weight assigned to that unit along with the error generated at the output unit. Okay, back propagation. Error calculated at the output unit is used in calculating the error at the hidden unit. Is it clear? We are going backwards. From the output unit, we are going towards the input unit. So first we have to calculate the error at the output unit. Okay, using this formula. Once we get this error, what you must do is you have to calculate the error at the hidden unit. Is it clear? We have to calculate the error at the hidden unit using this formula. Once you get the error at the output unit delta k and the error at the hidden unit delta h, next task is to update the network weight. See, as I said, neural network is all about weight updation, weight calculation and weight updation. So once you get the weight, what you must do, you have to calculate the weight for each layer. Okay, wji plus change in weight. So this change in weight is nothing but this change in weight is equal to, okay, new means learning rate into delta j, that is hidden layer error, into xij, into that particular input value. Is it? This is how we are going to update the input. Is it clear? One thing is provide the input, calculate the output, forward it to the next layer. We'll go on forwarding it to the final layer. Once you get the output, if it is not the desired output, what we'll do is we'll calculate the error, and we'll send back the error to the backward layers. Okay, by doing this calculation, we'll send the error back to the previous layers. In those layers, what we must do is we must calculate the weights of each and every leg network, and we have to update the weights using this formula. We have to update the weights using this formula. Is it clear? See, one example itself I will take and I will explain you, but it will take 2 to 3 hours to explain one complete working of neural network. Okay, I will take time, after test I will explain with an example how exactly neural network works. It is very complicated process. Okay, because at each and every layer you have to do the calculation. Lot of computation is involved. Okay, lot of computation means lot of computation is involved. It will take lot of time for the calculation. Okay, that is how. That is why in the beginning itself we have mentioned. See, neural network creation is complex. Its computations are complex. It will take lot of processing time because at each unit, so many calculations it has to do. While calculating the error or while forwarding the output, it has to perform lot of calculation. For this, that reason, it is a very complex algorithm, neural networks. So if the problem is on hand is complicated, then only we will make use of neural network. Okay. So in exam, either they will ask you this back propagation algorithm, and you have to write one network example and explain it, back propagation algorithm, or they will ask you to derive these two equations. Okay, these two equations derivation is there. They will ask you to uh, calculate the error at the output unit or hidden unit. So this simple derivation is there. This derivation they will ask in exam. Okay, case one, computing the increments for output unit weights for hidden unit weights. These two, in example, in textbook also case one, case two, they have given like this. This differentiation, simple differentiation. Okay, 5 to 6 lines differentiation steps are there. So these two, very much chances are there they will ask these two derivations in exam. And chances are also there they may give you one problem and they may ask you to solve it. We shall see whether I will try to solve a simple problem on this, but it's not that simple. Okay, when we talk about neural network, solving the problem is very difficult task. We shall think about it. And for the next test, you have decision tree, all the topics related to decision tree and neural network. Okay, including the derivations, problems, everything. In decision tree also you'll get the problems and theory. In neural network also you will have problems and theory. Okay, for test syllabus is complete decision tree and neural network. Don't go module wise. Okay, entire whatever topic related to decision tree will be there for test. Even neural network, complete neural network, it will be there for test. Okay, test will be simple. Problems will be there. You need to answer the problem, solve the problem. Is it clear? So this is the working of backpropagation algorithm. Same thing we'll do at each layer. Okay, at each of these layers, we are first thing is calculation of output, forward it, calculation of output, forward it, and we'll come to the output layer. At this layer, calculate delta K and send it back. At these layers, calculate delta H, error at this unit, and send it back. Here also calculate error and then update these weights. Okay, X1, X2, X3 are input. Here weights will be there W1, W2, W3. Okay, you need to update these weights. Is it clear? Calculate output, forward, calculate output, forward it. In the output unit, calculate error, send it back, calculate error, send it back. And at this point, update the weights, start updating the weights. That is how backpropagation algorithm works in case of neural network. Is it clear? Okay. You may mark the attendance. I will close the class here. I'll stop here. Okay. And then next I will take class after the internals. Syllabus, as I said, decision tree and neural network. Okay. Yeah. Thank you.